All right, I am choosing to do numbers 4 and 10 from worksheet 5 from last night, just so you guys can look at them and practice. You should be practicing everything before the quiz, but so you have a step-by-step walkthrough on these two problems. If I have time, maybe I'll do a third one. So, looking at number 4, we have a complex fraction. First thing you got to do is simplify the top and bottom. So, on top, we have to get a common denominator, and we notice that it's an x plus 1 for this one, so we have to multiply the other one, the 2, by x plus 1 over x plus 1. And then we have a minus 2. And I'm just going to combine them already because they have the same denominator. So what happens on top is it looks like that. 2x plus 1 minus 2 over x plus 1. So this is the top, and that simplifies to, you have to distribute the 2. So you get 2x plus 2 minus 2. So you get 2x over x plus 1. That's just the top fraction. Now let's do the bottom fraction. We need to, again, get a common denominator. This one is 2x minus 1 over x minus 1 plus 2. And sure enough, we now have a common denominator, so I made it one fraction. And we can distribute 2x minus 2 plus 2 on bottom of the big fraction. You get 2x over x minus 1. Okay, last step for this one. So this one's actually not that bad. Flip the bottom fraction and then multiply. So we get the top is 2x over x plus 1 times, I'm flipping the other one, we get an x minus 1 over 2x. Since we now have multiplication, we can start canceling like terms. Remember, this is also a grouping. The only things that cancel are the two x's. So the final answer for this one is x minus 1 over x plus 1. And that's all you can do with it. And this is simplified. Key to remember when you're adding and subtracting is when you're adding and subtracting, you need to multiply out the numerators and combine your like terms before you then start simplifying more. So, all right, that was number 4. I'm going to go to number 6 just to mention something real quick. Remember, we learned this last semester. That does not factor by grouping. Even if you try really hard, it doesn't work. You need to use your calculator to find the zeros. Oops, can't spell today. To find the zeros. Okay. Remember, graph it, look for where it hits the x-axis, and then use intersect, make your y2 0, and find all the zeros. I believe this one has 3 really nice ones, but if it didn't, you'd find the one that wasn't nice, or you find the one that is nice, and then synthetically divide. So that is that one. But I actually want to do number 10. I just wanted to remind you guys how to find the zeros of a polynomial. So, all right, number 10. There's a long way and a short way to do this. Of course, I will do the short way because it's the way you should be doing this. If you look at the bottoms of these 3 fractions, we have an x minus 1 and 1 minus x and an x plus 1. Remember, with pluses, you can rearrange this any order you want. So this says x plus 1. This one says x minus 1, and this one says 1 minus x. Whenever you see ones that are similar but just flipped around with a minus sign, always take out a negative and reflip it around. So what happens is, I can rewrite this as 4 over x minus 1. This is still a minus, but I have a negative 1 on the bottom, x minus 1, plus 2 over x plus 1. And what happens is you can take this negative 1, put it out in front, so this goes up to here, and this becomes positive. And then I can look at my GCF, or not my GCF, my LCD, lowest common denominator, and I know I have an x plus 1 and an x minus 1. So here's what I would do next. I'd make them all x plus, x minus, so I have 4x plus 1 over x minus 1, x plus 1. This turns into a plus again, like I said. So this is plus 3 times x plus 1, because this also needs a plus 1, plus 2 times x minus 1. And then the denominator is now all x minus 1, x plus 1. The next step, again, when you're combining, is you need to multiply out and add like terms. With multiplying, like this problem here, number 9, you don't have to do that. You just have to factor and then simplify. When you have pluses and minuses, you need to combine it into all one term on the top. So I get 4x plus 4 plus 3x plus 3 plus 2x minus 2 all over x minus 1 and x plus 1. So now I combine my like terms. 4, 3 is 7, and then plus 2 is 9. X. 4 plus 3 is 7, minus 5. All over x minus 1, x plus 1. And that should be the final answer. Can't do anything else with it. We have a common denominator. We added our like terms. And we simplified it. We can't take anything else out or cancel anything else out. So that's how you do number 10. Let's go back to number, I don't know, let's do a complex one again. I'm going to go back to let's do number 3. Number 3 looks interesting. I need to simplify the top and the bottom, so I will do that. I have a bottom of an x here, and then I have a top of an x plus 5, minus 5 here. So I need an x on the bottom, so I'm going to do x times x minus 5 plus 6 all over x. I just multiplied this by x over x, and then it turned into this. So the top is that. The bottom, I have to multiply the top and the bottom by x squared. So we get x squared minus 9 over x squared. So I'm going to simplify this now. So the next step is multiplying out on top. We get x squared minus 5x plus 6 over x squared minus 9 over x squared. We can now factor what we have. Two things that multiply to 6, either 6, 1 or 5 or 3, 2. In this case, we have a 3, 2. X minus 3, x minus 2, all over x. And then the divided by the fraction x plus 3, x minus 3, all over x squared. Final step, we take that bottom fraction, flip it, and multiply. So the top is still x minus 3, x minus 2, all over x. And then times x squared, all over x plus 3, x minus 3. And finally, we simplify by canceling out what is available to cancel. So I have an x minus 3 over here and here, and I have an x here, and I could take 1 away here. So my final answer for the problem is x times x minus 2 all over x plus 3. And that is, again, how you simplify a complex fraction. All right, make sure you do the whole worksheet, check your answers, and come with questions tomorrow.